Hello everybody, I welcome you all to NCAS Geology class. In my previous lecture, I have already discussed what is sampling, what is assaying, and I was discussing about the reserve estimation. In reserve estimation, I have already discussed what is reserve, what is resource, and how the reserves are classified into three types: proved, probable, and the possible ores, possible reserves. Then I have discussed how the average grade can be found out. Now let me discuss how the reserve estimation is being made after determining the volume of the ore deposits. Volume of the ore deposit can be found out by geometrical method, and it also can be found out by graphical method. Let me discuss the geometrical method. So in geometrical method, one type is that is included area method. It is adopted when the boreholes or pits are sunk in a grid pattern. This is the grid pattern. The samples are collected in a grid pattern. These are the sample points. 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 There is a regular spacing between the samples. The figure below is showing the boreholes at 25-meter intervals in a grid form. All the holes are mineralized. Assuming that the total reserves can be estimated only inside the big square area enclosed by the sample points, the area of influence of each sample points is shown in the figure. This is the sample point. The area of influence is about 12.5 meters and up to this 12.5 meters. So this is the area of influence. So this is the total area of influence of this corner sample. The same thing happens in all the four corners. This is the area of influence. But this sample, these side samples, they have, so here on this side is 12.5, on this side is 12.5, on this side is 12.5. So this becomes a rectangle having area 25 into 12.5 square meter. So all these sides, they have the area 12.5 meter into 25 meter. But what about these central squares? The area of influence is 12.5, 12.5, 12.5, 12.5. So this is the point where sample has been collected, and based upon the sample, its the consistency of the ore is extended in all directions at 12.5 meters away. So this becomes a square having area 25 by 25 square meter. So at the center of which there is a sample. So these are the squares. So we have got 6 squares. We have got 4 corners. We have 5. We have 10 rectangles. We have got 10 rectangles. So total area can be found out, and if the width of all these samples are uniform, then the total area into width will give the volume of the ore deposit. If the width is variable, in that case, block wise the volume is being calculated and total volume is found out by adding all the sub volumes. So the area of influence of the corner samples are 12.5 into 12.5 square meter each. There are 4 corner areas and there are rectangles having area of influence of 12.5 into 25 square meter each for 10 numbers of rectangles represented by side samples. And in the center there are 6 squares having area of influence 25 by 25 square meter each. So the total volume of this block of ore deposit accounted for by 20 samples is V, which is equal to 4 into the corner areas into their width W1 plus 10 side blocks with their width W2, 6 central blocks each having area 25 by 25 with, if their width is W3, then 6 into 25 into 25 into W3, it gives the total volume. So if the corners have the width W1, side rectangles have the width W2 and the center squares have the W3, then V becomes, this is the value of V. This volume is multiplied by specific gravity to find out the tonnage in metric tons. The average grade will be 1 by V into V1 G1 plus V2 G2 plus V3 G3 divided by total volume, that gives the average grade. So this is the case when you talk about the included area method, because the sample points, they define the limit. These are the sample points. These are the sample points. So that define the limit of the area. The area of influence is coming within the line at which the samples have been collected. So it includes the samples, they include the area, that's why the name is included area method. Now let us discuss the extended area method of calculation of the volume. In extended area, the area of influence is taken into account. So this is extended area method. It is similar to included area method, but the boreholes provide samples in a grid pattern as shown below. Each sample has the same area of influence. The boreholes are placed at 25 meter apart. This the distance between the 25 meter apart, and the area of influence of each sample is found out. This is 12.5, this is 12.5, this is 12.5, this is 12.5. So it becomes 25, it becomes 25, at the center of which the sample is located. So the area of influence of this sample point has been extended beyond the sample point sideways by 12.5 meters. So 12.5 meters, 12.5 meters, 12.5 meters, 12.5 meters, extend further. That's why it is called the extended area method. The consistency of the sample is found to be uniform for this whole block. So all the blocks are estimated that they have their uniformity in the occurrence of the ore body. In each block there is uniformity in ore body because its area of influence has been found out. The sample is here So its area of influence is 12.5, 12.5, 12.5, 12.5. So in this block, this sample presents the uniform quality in the entire block. So as the area has been extended, that's why this method is called extended area method. So we have at the center of each block a sample point. So we have here 85 blocks, each block having area into 25 into 25. If all the blocks they extend to a common depth W, then that is multiplied by W to give the total volume. So area into depth, area into depth. Here the samples are collected in a grid pattern, and in this manner we can find out the volume. As the area has been extended beyond the sample points, the method of calculation of volume here is described as the extended area method. So each sample is having its own area of influence, 12.5 meters along and across every sample point. So each sample point has a square in which the mineral is found to be uniformly present. If the mineral is a bedded deposit and extend to a common depth say W, then the volume of the deposit is found out by V, which is equal to 25 into 25 into 25 into W1 cubic meters. Then the specific gravity is multiplied to give the tonnage, and if the grade is uniform, simply grade is multiplied. If the grade is variable from block to block, then individual the blocks, the grades of blocks are found out and then added up to find out the average grade. So this is the case when you talk about the samples which are collected in a grid pattern and the area of influence has been extended beyond the sample points. Now let us come to the third method, which is triangular method. Here the samples are collected in a irregular manner, not in a grid pattern. Here the sample point, here the sample point, here the sample point, here the sample point. So the sample points are being joined, they are being joined. So at the corners we have the samples. If it has width W1, it has width W2, W3, then the area of this triangle is found out. Then the width, average width is W1 plus W2 plus W3 by 3 is multiplied with this area to get the volume of this block. Similarly, the volume of this block is obtained, the volume of this block is obtained, volume of this block is obtained, and they are being added to give the total volume. So this is the way how triangle method operates. That has been discussed here. So same way, but here the samples are not in a grid pattern. Now let us discuss polygon method. Here polygons are being drawn around the sample points. Here the samples are not in a grid pattern, but in between the samples perpendiculars are drawn at the middle point. In between the samples perpendiculars are drawn. So in this manner the perpendiculars are drawn and we find the formation of polygons around the sample points. So each polygon is having the sample at its center. So these polygons are, so this, if this is the sample, its area of influence is extending up to this. If this is the sample, the area of influence is going up to this. So in this manner the polygons are constructed around the sample points. If the width of each block is different, then they are found out, and the area of each block is found out by planimeter. It is multiplied with the width to give the volume of this block. Similarly, the volume of this block is found out, the volume of this block is found out, the volume of this block is found out, and again all the blocks, they are being added up to give the total volume. Once volume is determined, the tonnage can be found out by multiplying it with the specific gravity. So this is the way how the polygons operate. And so I discussed all the 4 methods of determination of volume by geometrical method. Now let me discuss how volume is being determined in graphical method. There are 3 ways: use of isocurve maps, use of stratum contours, use of transverse sections. These are 3 methods by which we can calculate the volume. So let me discuss what is isocurve maps. Isocurves are the lines that join points of equal vertical thickness of beds having deposits of minerals with uniform grade. Say it is a coal deposit. In the diagram below, the isochore lines have been joined with values 5 meter, 5.5 meter, 6 meter and 6.5 meter. So this is the isochore line having depth, having vertical thickness 5.5 meter. This is another isochore line having vertical thickness 5.5 meter. This is another which is having vertical isochore thickness that is 6 meter, it is 6.5 meter. So the outer bound is 5 meter, then 5.5 meter. So the average thickness is 5 plus 5.5 by 2 is the average thickness for this area. So this area is found out by using planimeter, and this area, if it is A1, it is multiplied with this thickness to give the volume for this block. Similarly, volume for this block is found out, volume for this third block is found out, the volume for this fourth block is found out, and all the blocks, all the volumes are being added up to give the total volume by use of these isochore maps. That has been discussed here. So the area between the contours of 5 and 5.5 meter will have an average vertical thickness of 5.25. Similarly, it is calculated for other contours. The area between the contours are calculated by use of planimeter, such as A1, A2, A3, A4. These areas are multiplied with their corresponding average vertical thickness to get the volume for each area. Finally, all the volumes are added to know the total volume of the above deposit. Then use of stratum contours. Stratum contours are the planes of reserve estimation where contours are drawn for the upper and lower bounding surfaces of the dipping ore body, say roof and floor contours for the coal bed. Let us say it is a dipping coal bed or dipping coal bed, a dipping coal body. So this is the upper surface, this is bottom surface. Contours are drawn for the upper surface and the lower surface. So let us say this is the ore body is occurring like this. So this is the area within the So the upper surface line will come up here, the lower surface line will come up here. It is projected, so it will be here, it will be here. So if I cut the whole body horizontally, let us say it is at a depth of 10 meter, the shape of the whole body is like this. This is the upper bounding surface, this is the lower bounding surface. Our body, so in this manner, the upper body is occurring like this. So it is like this, occurring like this. So it is being projected, line will come up, and this is also projected, the line will come up like this. So this area, so this is the area at a depth of 10 meter through the whole body. Let me further make it clear by a neat diagram. Let us say this is a whole body dipping like this. So this is the upper surface, this is the bottom surface. So if I take a section, this line will come up here and this line will come up here. So this is a horizontal section through the whole body. This is the upper surface, this is the lower surface. This is the upper surface, this is the lower surface. Let us say it is the area at a depth of 10 meters. So this area we found out, this horizontal area within the whole body. Let us say at 10 meter the area is like this. At another 20 meter depth, another 10 meter depth, the area is like this. So this is the area A1, this is area A2. Let us say at 30 meter it is of this type. So it is A3. So that means this A1, A2, A3 at the horizontal areas through the whole body at a depth of 10 meter, 20 meter and 30 meter. We can take A1, multiply it with 10 so that this volume is found out. Then A2 with depth 10 meter, then this volume of A2 is found out. Then A3 into its depth, the volume of A3 is found out, and they are being added up to give the total volume. So stratum contours for upper and lower surfaces are found out, the area between them is found out, and the depth extension of the whole body is multiplied with that to give the volume. That has been discussed here. So the upper surface and bounding surface, bounding surface, lower bounding surface are drawn at 10 meter depth, 20 meter depth, 30 meter depth and 40 meter depth. So these are the stratum contours, or they can be called as the floor contour, roof contour. The contour interval is 10 meters. A, B, C, D are the shape of the whole body at 10 meter, 20 meter, 30 meter and 40 meter depth. Each of the horizontal areas A, B, C, D are measured and are multiplied with the vertical depth of influence, that is 10 meter, to find the volume for each block. Then total volume is found out by adding all the volumes at A, B, C and D. Or we can take the average of A1 plus A2 plus A3 plus A4 divided by 4 into total depth. It may be 40 meters. That will give you the volume. So in this way the volume is found out and once the volume is found out, the reserve is calculated by dividing it, by multiplying it with the specific gravity. Then let us discuss what is use of transverse sections. In transverse sections, the boreholes are given in a grid pattern, in a line. Let us say at 60 meter interval, the boreholes have been given. So here, how is the underground mineralization up to certain depth? That is found out. That is found out. So we can, let us say, in this borehole, here there is high grade ore, here it is medium grade ore, it is low grade ore. Here high grade ore, here medium grade ore, here low grade ore. High, medium, low. High, medium, low. So all highs are joined together. Joined together. Joined together. So this becomes high grade. If this is the ground surface, this becomes high grade, this becomes low grade, medium grade, this becomes low grade. So this is a transverse section. In a particular line, we have four boreholes, and the transverse section is like this, or transverse section is like this. This is one type of deposit, let us say high grade, this is medium grade, this is low grade. So this is a transverse section in one line. Let us take another transverse section at 60 meter interval. Here 4 boreholes, and then the area is found out here. The area of is found out here. Let us say high grade, low grade, medium grade, low grade. Then we take another transverse section where the high grade, low grade, medium grade, they are found out at a 60 meter interval. So we have three sections. Sections interval is 60 meter. Here the area of A1 for high grade, here it is B1 for high grade, here it is C1 for high grade. So A1 plus B1 plus C1 into 60 meter, that gives the high grade variety in this zone. This is area of medium grade A2, B2, C2. So these areas are added up and their spacing is 60 meter, that is multiplied. So this gives the medium grade over the volume of medium grade. Similarly, the area of low grade is found out, they are being added up, and finally the volume of the low grade is found out. In this manner, by using transverse sections, we can find out the reserve. So that has been discussed here. Let me again discuss the same thing by going through my manuscript. Transverse sections are used for estimation of reserve in bedded deposits such as limestones and iron ores. In the figure below, there are 16 boreholes which have been sunk in grid pattern at 60 meter interval to estimate the iron ore reserve. There are 3 types of ores. Let us say massive steel grey ore, laminated hematitic ore, and limonite ore. The reserves of each type is estimated separately. 4 transverse sections are drawn using the data of drilling, and the shape of these types of ores are constructed. In each section, the area of each type is measured by a planimeter. Let the area of these 3 types of be A1, A2, A3 in section 1, B1, B2, B3 in section 2, C1, C2, C3 in section 3, and D1, D2, D3 in section 4. Then A1 plus B1 plus C1 plus D1 into 60 will give the total volume of the massive steel grey ore. Similarly, A2 plus B2 plus C2 plus D2 into 60, that gives the volume of the laminated hematite. And A3 plus B3 plus C3 plus D3 into 60 gives the volume of the limonitic ore. So here the diagram, borehole 1, 2, 3, 4, and from the borehole data the area of extension of the deposit have been found out. This is one type ore, this is another type ore, this is third type ore. Same thing, this is one type ore, this is another type ore, this is third type ore. So the area of each type is found out. This is A1, this is A2, this is A3. B1, B2, B3. C1, C2, C3. D1, D2, D3. And all are 60 meter apart. That's why the way the volume has been found is calculated, that has been described here. And first thing is we have to find out the area by taking the borehole data placed in a grid pattern. This is the surface and how the ore body is extending downwards by taking the data of borehole data. So after this area is found out, the areas of the four sections are correlated and then the volume is found out. So this is the way how transport sections are being used to find out the reserve, find out the volume and then the reserve. So this is all what I wanted to discuss, to find the volume and then the reserve. I have tried my best to explain in the most possible way how the reserve is being estimated, and I thank you all for giving a patient hearing to my talk on this reserve estimation. Thank you all.